So the difference between just regular inequalities and system of inequalities is a system is when we have two or more. So a system is when I have two or more linear inequalities. So just like when we had systems of linear equations, we had two or more equations. Now we just have two or more inequalities. So we're going to look at the solution of a system, which is any ordered pair that satisfies all inequalities. And that just means the solutions are in the double shaded region. So we're going to look at two inequalities. Both of them are going to have their own shaded region, and we want the one that is both of the shaded regions for both of the inequalities. That's called the double or overlapping shaded region. So the graph of the following linear inequalities is shown. So we have the inequality y is greater than x plus 4, and we have 4x plus 3y is less than or equal to 12. So those two inequalities are graphed here. So we'll call this region A, and we'll call this region B, region C, and region D. So region A is where both of our lines are shaded. Both of our lines are overlapping. We have some shading in region B, some shading in region D, but both of the inequalities are shaded for region A. So we're going to figure out which one is our solution region. So to verify a solution region by checking points from each region, a point must satisfy both inequalities to be a solution to the system. So I'm going to highlight that. It must satisfy both inequalities to be a part of the solution region. So we're going to complete the table. We're going to use T for true and F for false. So for each point, so this point is -6, 0. We're going to take the first number, which is -6, and we're going to substitute it in for the x. And we'll take the second number, which is 0, and we'll substitute that in for the y. So it's y is less than x plus 4. So 0 is less than -6 plus 4. So then I can do a little bit of math. 0 is greater than -6 plus 4, which is -2. So that is true. 0 is greater than -2. And now we're just going to do the same thing for the other inequality. So in this inequality, we're going to substitute -6 for x and 0 for y. So then we have 4 times -6, which is -24, plus 0, which is just 0. And that is less than or equal to 12, which that is also true. So if both inequalities, we're going to say yes, because it's true for both inequalities. If it's true for both inequalities, yes, it is a solution. That's the thing. If it satisfies only one of the inequalities, it's not going to be a solution. So we're just going to go through each coordinate, and we're going to substitute the x and the y, and we're going to determine if it satisfies one or both of the inequalities. So 6 is greater than 0 plus 4. So 6 is greater than 4. That is true. And then we have 0 and then 6 that we have to substitute into our second equation. 4 times 0 is 0. 3 times 6 is 18. 18 is not less than 12, so this one is actually false. No, it does not satisfy both inequalities, so no, it is not a solution. All right, so we're going to just keep going with each of these. The x is 6, the y is 0 this time. So everywhere there's an x, we'll substitute 6. Everywhere there's a y, we'll substitute 0. So this first one, 0 is greater than 6 plus 4, which is 10. That is true. And then we have 6 times 4, which is 24, is less than or equal to 12, which that is not true. That is false. So no, it does not satisfy both of the inequalities, which means no, it is not a solution. So for this one, x is 0, y is negative 6. So now we just simplify. Negative 6 is not greater than 4, so this one is false. And then negative 18 is less than 12, so this one is true. It does not satisfy both inequalities, so it is not a solution. If we get one true, one false, it is not satisfying both inequalities, which means it is not a solution. We have 4 more points. So negative 4, 0. Plug in 0 for y, negative 4 for x. So for this one, 0 is greater than 0, which that's not entirely true. 0 is equal to 0, so that one's false. And we have that negative 16 is less than or equal to 12. Well, that's true. Negative 16 is less than 12. But it does not satisfy both inequalities, so no, it is not a solution. All right, so this time x is negative 3, y is 8. So we have 8 is greater than negative 3 plus 4. So 8 is greater than 1. That is true. Then I have 4 times negative 3, 3 times 8, which this one we'll have to do a little bit of extra math. So that's negative 12 plus 24, which negative 12 plus 24, that's equal to 12. 12 is less than or equal to 12 because it says equal to. So this one is also true. So it satisfies both of the inequalities, yes, which means it is a solution. So when we get 2 truths, yes, it satisfies both, and yes, it is a solution. This time we'll use 2 for x and 6 for y. So we have 6 is greater than 2 plus 4. Which 6 is not greater than 6. 6 is actually equal to 6. So this one is false. Plug in 2 for x and 6 for y. 4 times 2 is 8. 3 times 6 is 18. So 8 plus 18 is 26. But 26 is not less than or equal to 12. So that one is also false. 2 falses. It does not satisfy either of the equations or inequalities, which means no, it is not a solution. So the only time it's a solution is if it satisfies both inequalities, and both inequalities are true. The last coordinate that we have to check is 3, 0. So the x is 3, the y is 0. We have 0 is greater than 3 plus 4, which 0 is not greater than 7. That's automatically a false. We still have to check the second inequality. 4 times 3 is 12. 12 is less than or equal to 12. Well, that's true. But no, it does not satisfy both inequalities. So no, it is not a solution. All right, so I'm going to go back and I'm going to highlight the 2 coordinates that say yes, it is a solution. So there was my yes, And here's another coordinate where, yes, it was a solution. So I'm going to go back up to this graph, and I'm going to put both of these points, so negative 6, 0. That's this point right here. And then the second coordinate, which was a solution, is negative 3, 8. Go over to negative 3 and up to 8. Okay, so the red points are solutions. And there's a rule that says if it's on the solid line, so if the point is 1 on the solid line, or 2 in the double shaded region, then it is a solution. So those are the two things that we need to remember. In order for a point to be a solution, it has to either be on the solid line or it has to be in the double shaded region, the region that is darker than the other ones. So in this case, region A is our solution region. Because that's where my darker shaded region occurs. And that's how you determine if a point is a solution or not, if we're given a system of linear inequalities.